coordinate to the polar coordinate, then you have to change the internal representation. But the conversion doesn't have to happen to the rest of the program. It only has to happen once to the subroutine itself. Is that making any sense so far? But with my other program, which seemed to be the smarter way of doing things, right now, doesn't seem so smart anymore when my boss told me to change the coordinate system. Because anywhere I have direct access to .x throughout the entire program, I have to change every single one of those. Everywhere I have a .y represent the .y destination, I have to change every single one of those as well. Because guess what? The data structure or the record won't have x, y anymore. Instead, it will have r and theta, which is the radius and the angle, instead of x and y. Is that making any sense so far? Are you guys kind of following the logic of doing this? But someone can still say, attack, that's not a big deal. This is only one line. What is the big problem of replacing a single line to a radius times, in this case, cosine, as opposed to making changes to these two lines instead? Well, it all depends on how much you sprinkle stuff like this. Okay, if you have in your program, if you have 200 places where you have to initialize the coordinate of a point based on the xy coordinate, you will have 20 of these invocations. 200 of these invocations. And if you use this approach, none of those has to be changed. Okay? None of these have to be changed because you are changing the subroutine itself to handle the new data representation. On the other hand, if a program is using this approach and there are 200 instances of this sort of stuff, then you have to fix all 200 instances of directly accessing x and directly accessing y. I mean, which program would you rather be working with? I want to work with this one. Okay, so the importance of abstraction using a remote control basically is something that you cannot see when a program is only, let's say, 50 lines, 100 lines, or even 500 lines. Okay, because you only have so many instances of these lines. But it does become more and more important as your program gets larger and larger, because as the program gets larger and someone sprinkles code like this all over the place, every time you make a change to the record type, potentially all of those lines need to be changed. Okay. Is that making sense so far? Now, they're both syntactically correct. They're both logically correct. It's just a matter of, is this programming practice going to be scalable? Can I write big programs using this approach? Can I write big programs using this approach? And that's why, in a college or even in a university, you probably won't come to appreciate the convenience of having an abstraction layer like in this case. Okay, this is called abstract data type. Okay, so I'm using abstract data type in the first version. In the second version, by accessing X directly, I am not using abstract data type anymore. Okay. Any questions about the concepts of abstract data type, why we want to use it? Anytime you want to kind of get reminded of what is abstract data type and why it is useful, just remember the television analogy, because that's basically why. I mean, you have a remote control that is universal. It talks to you as a consumer in terms that you understand, instead of terms that are just directly based on the technology behind the display. Okay, and it's the same thing here. Because you don't want to relearn how to use a remote control every time they change the technology. And it's the same thing with programming. You don't want to change the program massively every time you change the representation of something. Okay, are there any questions about this? No questions? Okay, that was easy. And remember, the abstract data type is not a programming language feature. It is a programming discipline. Okay, it is a particular way of programming. save this. Now let's go ahead and take a look at how we can mix and match arrays and records, because those two things are not related. Okay, so they can be mixed and matched without any problems. So what we'll do is we'll first define a particular type that has an array in it. Or we can do it the other way around too. We can just say, okay, let's say we keep the coordinate thing, because we have used it and it's easy to understand. So we'll keep the same thing here. We have a type called coord, which is the same way as before, so there's no need to copy that. And in this case, I'm defining a program called main again. But I have a local variable that is an array. My local variable called A is an array of, let's say, 2 coord. And here I want to do something about it. Let me see what I want to do. Let me first just say that I want to initialize the second element of the array, and I just want to initialize the y component of that to a value of 201. Once again, we have a program that is useless other than illustrating the concept that we want to illustrate. Okay, so here's the program. And the trace is going to be pretty much trivial, but what we want to see is how does A look like? Okay, what is the shape of A? What is the structure of A? We'll do it in the trace window. We'll go ahead and save the file first. I'll call this records in an array. The first part, not very interesting, because we have the precondition, and we start with line 9, which has a return line number, and of post. Okay, so that's the easy part. Almost every program from now on will have these 2 columns pretty much initialized similarly like this. What is interesting is, what about A? I know A is a local variable, so we have to allocate columns for A. How many columns do I need to allocate for A in this case?
Only 2 are necessary. Only 2 are necessary.
Well, let's take a look let's take a look at the array itself. Local A, colon means is A. Okay, so every time you see a colon in this type of pseudocode, you can just interpret the colon and say that, oh, it means is A. Okay, so in this case, array local variable A is an array of 2 coords. Okay, how many columns do we need to store an array of 2 coords? 4 columns. Okay, because each coord has an X and a Y. So each coord takes up 2 columns already. And we have 2 of these things, so we need 4 columns to represent the entire array. So that means if I want to display the structure of local variable A, first of all, A is one single thing that takes up 4 columns. Okay? Whenever I refer to A all by itself, I'm referring to column C all the way to column F. Okay? And sometimes it's handy to look at it as one single thing. Other times I want to access individual items of array A. But because A is an array of 2 elements, I can break it up into 2 components initially. The first component is just A bracket 0 for the first element and A bracket 1 for the second component. So that means every time I say A bracket 0, it refers to both column C and column D. Every time I refer to A bracket 1, it refers to both column E and column F. What do I need to do to access column C and column D? Column C is the X component of A bracket 0. Column D is the Y component of A bracket 0, and likewise for column E and F. Okay, are we doing okay so far with how I designate the names of the columns? So let's go ahead and make this a little bit more compact because we don't really need all that space. And this time I remember to make sure that everything starts with unknown values. Then we can go ahead and execute the only line inside main, line 7. Line 7, if you look at the notation on the left-hand side of the assignment statement, does it look confusing to you? No, because you just have to read it step by step. Okay? The mixing and matching of brackets and dots should not surprise you at all, because what you do is you just read it from left to right. You start with A. A is an array. Okay? What can we do with an array? I cannot put a dot after an array because an array does not have components that are designated by name. It only has components or elements that are designated by numbers. So it makes sense that I have a bracket, square bracket notation right after A, so I can specify which element do I want to access within the array. In this case, I want to access the second item, which has an index of 1. So that covers A bracket, 1 close bracket. But what is A bracket 1? A bracket 1 by itself is a cohort. Okay? What can I do with a cohort? Well, many things, but one of those many things is to specify, oh, I want to access the Y component of that cohort, because Y is one of the components of a cohort. So as a result, in this case, A designates that we want to access something within column C to column F. A bracket 1 specifies I want to access something within column E and column F. And A bracket 1 dot Y designates a single column, in this case column F, and I just want to change that one column to a value of 201. And that's it. Okay, I know the rest of the program doesn't. This program does not really do anything useful, but all it does is to illustrate what it looks like. Okay, when you have an array of records, and in addition to that, how do we access a single column when you have an array of records? Oops. And on line 8, we deallocate everything, and then we continue execution based on the return line number, which means we're going to post. We're all done. So we'll go ahead and save this program. We have just enough time to cover one last sample program, which is basically the reverse of this. We have a record that has an array inside. Okay, so how do we access elements of an array that is inside a record? So we'll go ahead and close this. Open up a new spreadsheet for that. Okay. So now this time we have. I will use this again. Okay, so this is one of those other programs that are useful, that will be useful later on. The name of the record is a queue, and inside I have several things. I have head index, I have size, and I have to designate the type of each one these days because we have talked about types already. So everything has to have a type. And I have items as an array of integers. In fact, I will have to say how many integers. Let's just say 4 integers. And record. And just like with the previous program, all I'm going to do is to define a particular subroutine with a local variable, in this case that is a queue. I'll call the name of the variable buffer. So buffer is a queue, and I want to access a particular thing in the items. So in this case, buffer itself is a record. I cannot do indexing right now because buffer is not an array. Buffer is a record. Which component of buffer is an array? Items. So now I can say, let's go to the subcomponent.